Okay, we're going to take a look at the paper very quickly, Rural Roads, Agricultural Extension and Productivity by Messe Gebrselassie. And this paper is a pretty straightforward paper. As the abstract suggests, the basic idea is to measure the effects of expanding rural roads and expanding agricultural extension. By agricultural extension, Gebrselassie and others mean extending knowledge about good farm practices or effective farm practices or new farm practices, new crops, new inputs like pesticides or herbicides, new ways of doing things, extending those from the research community, the agronomists and other crop scientists who work on improving farming and crops, extending that research down to the level of the farmers so that farmers can increase their productivity and hence their profitability and hence their incomes by adopting newer and more effective technologies. So we already saw that with the fertilizer paper, that process by which research scientists are going and investigating new techniques and then disseminating them through agricultural extension agents to the farmers. We also saw it in the DrumNet export agriculture paper. And we saw it in a bunch of videos where we had farmer schools, farm extension services. So we want to look in this paper, Gebrselassie is looking at, well, what's the impact of agricultural extension? And of course, rural roads, we know, think of it more broadly as transport infrastructure. Reducing transportation costs is going to raise profitability of some crops because now it'll be less expensive to transport them to the markets where they are desired by consumers. We might imagine that there's a point where reducing the transport cost actually makes it profitable to cultivate the product. So you might imagine something like pineapples are very heavy. If they have to be transported across unimproved rural roads, full of holes and get stuck in the mud in the rainy season when the when the pineapple needs to be transported, but the trucks are really heavy because they're full of pineapple. So it's not profitable to grow any pineapple. Once you get an all-weather road, a tarmac road, an asphalt road there, the costs of transporting this heavy product might be very much diminished, and all of a sudden it becomes profitable to grow the crop in the region. So transport costs are going to matter for many kinds of crops, not for all. Many crops, the transport's just a small percentage of the value, but for some crops, the transport cost might be a very high percentage of the value. So we think that rural roads and agricultural extension might both increase productivity in farmers. But we also, Gebrselassie point, very straightforward, very simple, is that each one alone might not do that much, but when they're together, that might be a powerful interaction. And it's that interaction that generates the big increase in productivity. So that's what he's measuring. And we can jump straight down to the table 1, which is the main table of interest. So let's take a look. Here's the example of the road network that we have in Ethiopia. So the I believe it's the pink lines are the new roads that have been built. You can see these are what are sometimes called feeder roads. So the black line is the main road that's already existing, connecting many of the towns. And then there are towns that are far away from the main black road, and these feeder roads then reduce the cost of transport away from these towns that are further away. And you might not think, well, what, 20, 30 kilometers, what difference does that make? I'll tell you just from personal experience in Burkina Faso, 30 miles going on a regular dirt road, especially in the agricultural season, can take sometimes 4 hours. Going on a tarmac road can sometimes take 30 minutes to go that same distance. So we're talking about quite a big improvement in timeliness of getting stuff to market once you go to an all-weather road. So that's the visuals here. And if we go down to the table, sorry. Very simple regression specification. So we have a variety of outcome measures: production value per hectare, value added per hectare, or a slightly more complex measure of productivity, total factor productivity, that some of you probably have seen in your macroeconomics classes, where we talk about total factor productivity in the context of the solo growth model, if you remember that. So these measures are measured at the individual level, but the individuals are clustered in villages, and so we have dummy variables in these regressions for every village. So we have village fixed effects. So if there are 500 villages, we have 499 dummy variables. So we're only looking at the variation in individuals getting access to roads, controlling for the fact that they're living together in villages. And we also are controlling for years, because some years might be higher or lower productivity. So we want to have dummy variables for every year to take into account that on average, maybe farmers are all increasing together in the years of good rainfall and good weather, and then they're all declining in the years of bad weather. So we have those as fixed effects, as dummy variables in our regression. So then what do we have? We have three specifications: one with just road as the explanatory variable, another with just extension as the explanatory variable, and a third with road and extension and the interaction term of the variables in the regression. And we see road alone has some positive effect on productivity. Extension alone has positive effects on productivity, but really it's when they're interacted, when you get roads and extension together. These are dummy variables, so 0, 1 variables. So this interaction term is also a dummy variable because it only takes on value 0 or 1. When it's 1, it means you're in a place, in a village, where there's a road and there's extension service, and that's where productivity goes up by almost 10%. But the coefficient on road alone is -4, so 10 minus 4, your productivity goes up by about 6%. And that's what we find across the regressions. Just one other thing in terms of these regressions, our dependent variable is log. And so remember from Stock and Watson, we interpret a log linear regression. We interpret the coefficient by multiplying it by 100 and saying then that an increase in the explanatory variable by 1, or in this case, being in the category, defined by the dummy variable, being in that category, increases the output by the coefficient times 100%. So production value per hectare goes up by 6%, value added per hectare goes up by 6%, and TFP goes up by about 7% in this case, 12 minus 5. So that's how we interpret these regressions. So pretty straightforward. There's a lot of other interesting discussion in the paper about why is it that productivity goes up, what explains this decline in productivity in the villages that get roads but don't get extension. Why would that happen? So lots of interesting stuff in the paper that I'll leave it for you to discuss and raise maybe in class.